scientists at NASA as the James Webb Telescope unfurled its gold-plated mirror.
Telescope, ever launched into space, made another successful step on its journey to a point 1,000,000 miles away from Earth today.
When the James Webb Space Telescope turned its golden mirrors toward a seemingly unremarkable patch of deep space, no one could have predicted what it would uncover. Scientists had selected the area as part of a routine deep field survey intended to explore the very limits of the observable universe. It was one of those essential methodical observations meant to stretch our knowledge of the early cosmos. But what the Webb telescope revealed was anything but routine. It was, in fact, so strange, so unexpected, and so unsettling that it sent shockwaves through the global scientific community and far beyond. Before we start, smash the like and subscribe buttons for more updates. At the center of the controversy was a discovery that defied everything astrophysicists thought they knew about the age and structure of the universe. The telescope had captured light from several massive, mature galaxies that appeared to exist a mere few 100 million years after the Big Bang. That timeline, if confirmed, would completely dismantle the current cosmological model. These galaxies weren't the tiny, chaotic, still-forming collections of stars one might expect from the dawn of time. They were vast, organized, and redshifted to a degree that made their position in space-time not just surprising, but impossible by prevailing scientific standards. The world's most powerful space observatory had seemingly peered into a time before structure was supposed to exist. These galaxies weren't just early, they were ancient by structure, formed, evolved, and matured when the universe should have still been in its turbulent infancy. The implications were immediate and profound. Cosmologists began to whisper what they dared not say publicly, that the standard model of cosmology might be fundamentally flawed. The very scaffolding that underpinned decades of astronomical research and theory, the lambda CDM model, the inflationary model of the early universe, the dark energy equation of state, everything seemed suddenly in question. But it wasn't just the age and size of these galaxies that sparked alarm. Deeper analysis of the data suggested they exhibited properties of dark matter interaction that weren't aligning with expected gravitational behavior. The stars within them rotated in patterns that hinted at either a new form of matter or, perhaps more disturbingly, a failure of Einsteinian gravity at cosmological scales. To the average person, these might seem like abstract scientific dilemmas, but for those immersed in the field, they struck at the very heart of reality itself. The unsettling discoveries didn't stop there. One of the more bizarre findings came from an ultra-deep infrared scan Webb performed of a high redshift quasar system. In the data, researchers detected what looked like periodicity, structured pulses of light that suggested either a repeating natural phenomenon never before documented or something else entirely. The pattern was too precise, too clean, and too consistent to fit into any known astrophysical category. Speculations mounted. Was this a new class of cosmic object? A relic of a civilization too advanced for our comprehension? A cosmic echo of some past unknown event? The unease deepened as artificial intelligence algorithms used to process Webb's enormous data streams began to flag anomalies with increasing frequency. Machine learning programs trained to detect gravitational lensing, galactic morphology, and star formation patterns began identifying objects that matched no known templates. Some appeared to have completely unique spectral signatures, indicating elements or conditions that do not exist anywhere in the periodic table. Others seemed to contradict the known rules of thermodynamics, emitting radiation in frequencies that should not be possible in the temperatures implied. These revelations weren't coming from fringe theorists or rogue academics. They were emerging from peer-reviewed institutions, NASA analysts, and globally respected astronomers who had dedicated their lives to understanding the cosmos. The Webb telescope, designed to peel back the curtains of cosmic history, was revealing something far more complex and enigmatic than anyone had anticipated. It wasn't just a look at the past, it was a glimpse into a version of reality that might be far more alien than comforting. Governments and agencies with a vested interest in space science took notice. Briefings were held behind closed doors. Data releases from some of the more peculiar Webb observations began to lag. While NASA and the European Space Agency continued to present new discoveries to the public with enthusiasm, certain datasets were becoming increasingly difficult to access. The public noticed. Amateur astronomers, science journalists, and curious minds on forums began to speculate. What was being withheld, and why? One particularly disturbing hypothesis started to gain traction among the more mathematically inclined members of the physics community. If the Webb observations were accurate, and if the redshift measurements were being interpreted correctly, then the concept of a linear expanding universe governed by relativistic physics might be incorrect. Some suggested that what Webb was observing wasn't the early universe at all, but something much stranger, an echo of a previous cosmos, a parallel space-time bleeding into ours, or most controversially, a simulation artifact, the cosmic equivalent of a rendering glitch. The unsettling part wasn't that these ideas were new. They had always existed on the periphery of scientific discourse. What changed was that they now had data. Theories previously considered philosophical musings were being pulled into scientific legitimacy by Webb's findings. The implications spread like wildfire, not just among physicists and astronomers, but across the broader scientific world. Biologists began to ponder whether life as we know it is truly shaped by stable physical constants. Chemists questioned the permanence of molecular behavior if the universal laws are fluid. Even mathematicians found themselves grappling with the idea that the very structure of logic might be subject to metaphysical context. While the James Webb Space Telescope had been expected to answer long-standing questions about the birth of stars, the formation of galaxies, and the evolution of the universe, it was instead asking new ones, unanswerable ones. The kind of questions that crack open the mind and leave an uncomfortable silence in place of certainty. What if time isn't linear? What if the observable universe is only a small fraction of a much larger multidimensional reality? What if our universe is not a product of randomness and physical laws, but intention, even if that intention remains unknowable? The mere possibility that Webb had found evidence pointing towards such radical ideas was enough to jolt even the most rational minds. The implications extended far beyond academia. Philosophers, theologians, and futurists began drawing their own interpretations. Some viewed it as confirmation that human understanding is forever limited by the lens through which it peers. Others saw it as a challenge, a call to evolve not just our technology, but our very framework of thought. Even the engineers who built Webb, men and women grounded in the rigor of precision and measurable outcomes, were privately expressing disbelief. No one had anticipated this level of disturbance. The telescope wasn't just acting as a cosmic mirror, it was becoming a portal to the unimaginable. For every answer it provided, it raised 100 more, and each of those seemed to gnaw at the foundations of our physical reality. And yet, none of this was presented with panic. That's not how the scientific world operates, but beneath the surface of calm statements and careful papers, a quiet urgency had taken hold. Entire teams were reassigned. Supercomputer time was suddenly diverted. Papers were retracted for further peer review. The world's brightest minds were waking up in the middle of the night with questions that had no analog in centuries of human thought. One particularly haunting piece of data came from Webb's survey of gravitational wave echoes, subtle distortions in space-time previously only detectable by LIGO and other Earth-based instruments. Webb's data suggested that these ripples were not random but aligned with specific sectors of deep space where other anomalies had been noted. It pointed toward a structured, repeating pattern, as though the fabric of reality was resonating with a frequency no one had previously tuned into. This wasn't noise. It was something that hinted at order, or at least intention, behind the universe's background hum. For decades, scientists have operated under the assumption that the deeper we looked into the universe, the closer we would get to understanding its origin. But what if the opposite is true? What if, by peering into the depths with unprecedented clarity, we're discovering not the simplicity of a singular beginning, but the complexity of multiple layers of existence? What if the cosmos is less like a clockwork machine and more like an endless manuscript with entire chapters written in languages we have not yet learned to read? Webb wasn't built to frighten, it was built to clarify, to illuminate the distant corners of space. But illumination often casts new shadows. It forces confrontation with things once comfortably ignored. The images pouring back from this magnificent telescope weren't just beautiful, they were provocative. They stirred a kind of primal wonder that bordered on dread, because for the first time in modern history, we weren't just asking how the universe began. We were asking what it is, and no one was prepared for the possibility that we might not be equipped to understand the answer. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the James Webb Telescope's new discovery? What's next? We want to hear from you. Thank you for watching, and see you next time.